Okay, we're back to factoring, and section 5.2 is on factoring trinomials. And I'm going to write something extra. So factoring trinomials in the form ax squared plus bx plus c. Okay? And in particular, this is the important part, a is equal to 1. Okay? In the next section, we'll learn where a is not equal to 1, and that factoring technique's a little bit more complicated. So we're starting out with the easier part right now. So for example, we might have something like x squared plus 12x plus 32. Okay? And notice that the a value, okay, we don't show it, but that a value there is 1. Okay? So what we want to do is we want to learn how to factor this type of problem. All right? So it's very simple. Okay? And I'm going to just show you how to do it, and pay very close attention. You're going to do this all the time for this particular trinomial when a is equal to 1. You're going to set up a table, okay? And you're going to put the c value right there. So this is the c value, okay? It's the constant, okay, this one right here. And then you're going to put the sum of the products. Okay, you may not know what that means yet, but what we're going to do is under this column of 32, you're going to put all of the products of 32 and then write down the sum of those products. And what should happen, okay, is one of those sum of the products, if it can be factored, will equal the coefficient of the middle term. Okay? So follow me. Let's write all of the products of 32. Okay, so let's say 32 times 1, 8 times 3, whoops, sorry about that. How about 8 times 4? Okay, 16 times 2. All right. Now we're going to put over here the sum. Well, what's 32 plus 1? You don't have to write that out, but I'm just showing you. That's going to be 33. And what's the sum? 8 plus 4. The sum is going to be 12. And then 16 plus 2 is going to be 18. Well, like I said, here's the 12, and you have 12 right here. So you know that these two values are going to be used to factor this. Okay? So if you kind of go backwards, or back a couple sections where we were using the distributive law or FOIL, where we were multiplying two binomials together, we'd get a trinomial, if you can remember that. So basically, the answer to this is going to be two binomials, okay, and will always be two binomials when you're factoring this type of problem. All right. So of course, you have an x and an x. That's our variable, because x times x, right, gives me my x squared, correct? And then now you can put the values of 8 and 4 anywhere you want. So plus 8, plus 4. I'll just put them that way. I could have put x plus 4 and x plus 8. It would still work out. So let's just check this to see if it's correct. Let's continue on with distributive law. So x times x gives me x squared. So I'm going to check this. So x squared. X times 4 is 4x. 8 times x is 8x. And 8 times 4 is 32. So this equals to x squared plus 12x plus 32, which is the same thing what we had to begin with. Okay, and that's how you check your result. You should always check. Just do a quick multiplication and see if you get your original problem back that you're trying to factor. So the concept of this is very simple. What's actually happening here, the reason why this technique works when you're setting up a table, is that notice when we actually multiply this out, we get a 4 and an 8, or a 4x and an 8x, right? So, and notice that 8 times 4, it's no coincidence that 8 times 4 is 32, okay? And this technique will work every time as long as a is equal to 1, all right? So like I said, the next section is going to get a little bit more complicated. So let's just do another example, all right? So let's say we want to factor t squared minus 11t plus 28, okay? So you have to think a little bit when you have a negative here. Well, it's no big deal. So let's just set up the same thing. Let's put down, remember, the c value, which is 28, and then we want to put the sum, okay? Now, notice that in order for me to write two products, okay, to get 28, so let me just give you an example. 7 and 4 would be 28, right? But also, a negative 7 and a negative 4 gives you 28, right? Negative times negative is positive. Well, we know that we're going to have to use the two negatives, because when you add them together, a negative 7 plus a negative 4 gives me right here this negative 11, right? So anytime you have the last term being positive and the middle term being negative, you know both of your values have to be negative, okay? So let's let me just erase this. Let's start over again. Okay, so the product's of 28. You start anywhere. I mean, you could start out with negative 28 and negative 1. Okay? And the sum is going to be negative 29, right? And we could do negative 14 times negative 2. And that gives us a negative 28. So remember, we're looking for that negative 11. Okay, and we already did it when I first started, but negative 7 times negative 4, and the sum is negative 11. And notice here, the negative 11 and the negative 11, that's what we want. So these are the two values that we're going to use. So when we factor this, it's going to be two binomials. So it says t squared, so it's going to be t and t, right? And again, it doesn't matter the order, but I'll just put it in the order in which I have written down. So minus 7 and minus 4. Again, let's quickly check ourselves. T times t. So this is the answer, all right? So this is just a check. So t times t is t squared. T times minus 4 is minus 4t. Okay, that was that part. Minus 7 times t is minus 7t, and minus 7 times minus 4 is a plus 28. So this equals t squared minus 11t plus 28, and that's our original problem. Okay, so I'm not going to check the rest of these, but you get the idea. But you should always check, and that's just going to verify whether you did the problem correctly or not. Okay? All right, let's try another problem. Let's say we want to factor, I'll write it out, factor b squared plus 8b plus 15. Okay, now some of these you may not even need to have to make a table. excuse me, for example, if you look at 15 and just what are some products that run through your head? Well, 5 and 3, right? Well, what's 5 plus 3? Well, it's 8. And there you have your 8. Okay? So, some are a little bit more complicated, but we'll do it anyway. So 15, and what's the sum? So everything's positive, so it's just 15 and 1, 5 and 3. Those are really the only options. So here we have 16, here we have 8. So there's the 8, there's the 8. So that's simply going to equal 2 binomials, which is b, going to be there, and then plus 5 and plus 3. So this is the factored form. Okay? Let's do another one. Let's say it's written this way, minus 39 plus 10x plus x squared. Now this may throw you off because it's not in the form ax squared plus bx plus c. So all you have to do is rearrange this. So write it as x squared plus 10x minus 39. Okay? Alright, so let's see here. Let's make our table. So minus 39 and the sum. Okay, so now this one's a little bit different because now we have a negative sign here and this is positive. So basically when we take the product of minus 39, one of the numbers has to be, or the number that's the largest number in that product has to be positive. Because when you take the sum, the sum has to be positive, right? So let's see. Let's forget about the sign right now, but we know that 13 times 3 is 39, right? But to get a negative 39, either the 13 has to be negative or the 3 has to be negative, right? Because a positive times negative is a negative, or a negative times positive is negative. Okay? But like I said, when we take the sum has to be positive. So the larger value needs to be positive. So the negative needs to go on the 3. So what's 13 added to a minus 3? Well, that's actually 10. Okay, and we don't need to go any further because here we have the 10 and we have the 10 right there. Okay? And really, the only other option would have been, 39 and negative 1, and that would have been a positive 38, and that doesn't work, right? So, this is going to be our result, or actually two values in our result. So this factored is going to be our two binomials, and that's going to be x plus 13 and x minus 3. Okay? All right. Now, there's some things that come up every once in a while that, might throw you off. So let's put in a multivariable polynomial. So let's say we have a squared plus 6ab plus 5b squared. Okay? Well, it's still of the form ax squared plus bx plus c. It just looks a little bit different. Okay? So, again, we're going to use the same technique. We put our 5 down, right, from there. Okay? And we want to know what the sum is. Well, there's not a whole lot of options for 5, right? Because 5 is a prime number, so it's just 5 times 1, right? And 5 plus 1 is 6. And there we have our 6 and our 6 right here. So the only thing you have to be careful about is how you write this down, right? So we know that a and a, or a times a, gives me a squared. Okay, that's fine. But remember the last one says b squared. In fact, it says 5b squared, right? So we know we have to have a b here and a b here. And then we're just going to put in plus 5 for 5b and then plus 1 for 1b, right? You don't need to put the 1 there. In fact, I would leave it out, right? if you input that as an answer, they may say your answer is correct, but it's not in the right form, and then I would just get rid of that one. So just get out of that habit. Don't write 1b, just write b. Okay? In other words, it's kind of the same thing as don't write b to the first power. Write this as just b. Okay? All right. Again, you can check yourself on this. Just use the distributive law and make sure you get the original problem back. Okay? All right. Now there are situations, remember we talked about the other day where there will be times where you want to factor out a -1. And so let me write this down. This would be one of the cases. You should factor out a -1 if the leading coefficient is negative. And it just makes things a lot easier to do that, because those negatives on the coefficient for the first term can kind of confuse the issue. The one I'm talking about, like minus x squared minus x plus 30. Okay? And remember, we always wanted this ax squared plus bx plus c. We wanted a to be 1. Well, in this case, a is not 1. It's actually -1, right? So let's make it 1. That's what we want to do. So we're going to factor out a -1. So I'm going to put a -1 here. Okay? And then -1 times x squared gives me minus x squared. -1 times positive x gives me negative x. And -1 times negative 30 gives me my positive 30. So these two are still equivalent. They're exactly the same. All right? So now, on this next line, we can factor this. So let's make our table. So minus 30 and then the sum. Okay? So remember, because we have a negative 30 here, we know that two values, one has to be a positive and one has to be a negative, right? And then the question is, well, which one is positive and which one is negative? Well, since this is a positive number, we know that the larger number must be positive. Okay, the larger number from the two factors of negative 30. Okay? So, I know this isn't going to work, but I'll say 30 and -1, and the sum is going to be 29. Okay? Then how about 15 and -2? Well, the sum is going to be 13. That doesn't work. How about positive 6 and -5? And the sum is going to be 1. Ah, there we go. This one, and here's the one right here for 1x, right? Even though the 1 doesn't show, that means there's still a 1 there, right? So now our result is going to be -1 times our two binomials. Well, usually you don't. Again, don't put that -1 there. Just put the negative sign. So, or the opposite sign like that, right? And then this will be x plus 6, and then x subtract 5. Okay? And where I'm getting those values are from right here. Okay? We'll do one more like that. Let's say we have negative m squared plus 18m minus 77. So again, I don't want this negative right there, so I'm going to factor out a -1. In fact, now I'll just put a negative here. I won't even put the 1 down. Okay? So you can put a negative, or you can say it's the opposite of. Okay? So the opposite of m squared gives you a -m squared. Okay. The opposite of a -18m gives you a positive 18m. Okay. And the opposite of a positive 77 gives you a -77. So again, this is just equivalent to this. All right. So now let's see. we have 77. Notice that our value here is negative, right? And this value for 77 is positive. So what are the options to give me a positive value? Well, two positive numbers, right? Like 11 and 7. Okay? But when you add 11 and 7, you get 18. And this says negative 18. So we know that both of our values have to be negative. All right? Oops. So, write this down here. Sum. Okay, so, we could put negative 77, negative 1. That's negative 78. That doesn't work. Negative 11, negative 7. That's negative 18. Oh, there we go. That works, right? Okay. And here we go. So this equals to the opposite of, and then our two binomials. So it's going to be m minus 11, m minus 7. Put this bracket a little closer. Okay. All right. Now, one thing, as I mentioned before in the last section, and I'll write this down, always look for a common factor first. That is there a GCF, a greatest common factor? Okay? If there is, you want to factor that out first before you do any type of other factoring. Factoring by grouping, or now this factoring of trinomials. Okay? So for example, let's say we have this question. We want to factor 5x squared minus 25x plus 30. Okay? Well, if you look at that right away, you might say to yourself, oh, well, this value right here, at least right now, that is not 1, and we haven't learned how to do that yet. So the next section, you could factor this right away, but you don't want to do that. You want to look, is there a common factor? And the answer is yes. The common factor, or the greatest common factor, I should say the greatest, not a common one, but the greatest common factor is 5. So we're going to factor out a 5. And we're going to go 5 times what gives me 5x squared? Well, x squared. And 5 times what gives me a minus 25x? So that's minus 5x. And then 5 times what is going to give me 30? Well, that's plus 6. Okay? So again, these are equivalent. But now we have our trinomial, right? So let's see. We can factor this. Now that may be it. We may not be able to factor this anymore, but let's see. So here's 6, and what's the sum? Okay, well 6, it's a positive 6, right? But then this middle term is negative, right? So to get that positive 6, we need to have two negatives or two positives. Well, it can't be two positives because the sum will be positive, so it has to be two negatives, right? So let's see. Minus 5 and minus 1 are really the only options, and the sum here is minus 6, right? So that doesn't work. Ah, yeah. Forgot about good old minus 3. Whoops. Sorry, let me back up. I messed this up. How about minus 6 and minus 1? That gives you sum of minus 7. Can't do basic math today. Alright, then we have minus 3 and minus 2. That gives me minus 5. Oh yeah, there's the minus 5. There's the minus 5 right there, right? So this can factor to 5 times, then the sum of then the product of two binomials. And then these are the values that I'm going to use, right? So x minus 3, x minus 2. And that is our final result. Again, you can check yourself, okay? fact, let me do it real quick. Let's do a check on this. So 5 times, well, x times x is x squared. X times minus 2 is a minus 2x. And then minus 3 times x is a minus 3x. You have minus 2x, minus 3x. I did that little step in my head. It's minus 5x. So you'll start getting the hang of that. And then minus 3 times minus 2 is going to be a positive 6. Okay? Now let's multiply this out, and that's going to be 5x squared minus 25x plus 30. And guess what? This is the same as this right here. Okay, so we know that we factored this correctly. All right. Let's try one more. So let's say we have 14n to the 5th minus 42n to the 4th minus 28n cubed. Okay? Well, this definitely is not in the form of ax squared plus bx plus c, so you should be clued off that, hey, I most likely need to factor greatest common factor out first. Well, we know the variable is going to be n cubed, right? Pick the lowest exponent for the common variable n, right? And then out of 14, 42, and 28, okay? Well, I know that 7 goes into 14. I know that 7 goes into 28. I know that 7 times 6 is 42. So it looks like it's going to be 7. All right? So that's my greatest common factor. And then times. Okay, so 7 times 2 is 14. N cubed times n squared gives me n to the 5th. 7 times a minus 6 gives me minus 42. N cubed times n gives me n to the 4th. 7 times minus 4 is minus 28. And n cubed is already there in the GCF, so we just leave that as a minus 4. Okay? Well, check this out. I actually did not. This is not the GCF. Okay? And how do I know that? Because there's still a common factor of 2. Because 2 goes into 2, 2 goes into 6, and 2 goes into 4. Well, it's no big deal. And I actually did this on purpose. Because now you would just take out the GCF right here. So there's no harm done. It's just you have an extra step. If I would have taken out 14 from the start, that actually is the GCF, because 14 goes into 14, 14 goes into 42 3 times, and 14 goes into 28 twice. But if you didn't get that, that's fine. But what you have to do is make sure you factor this out. So I'm going to go, this is the extra step then, so 7n cubed, all right, and then times then 2. I'm going to take out that GCF here. So GCF here is going to be 2. Alright, so here's that 2 right here. And just go 2 times what gives me 2n squared. Well, that's n squared. And then 2 times what gives me minus 6. Or, sorry, 2 times what gives me minus 6. So that should be minus 3, right? And then there's our n. And then 2 times what gives me minus 4. That's minus 2. Okay? So now this is where we get our 14 from. So 14n squared, that's the actual GCF, okay, and that's just n squared minus 3n minus 2. Well, are we done? Well, maybe, maybe not. Can we factor this last trinomial? Well, let's see. We have minus 2, whoops, minus 2 goes over here on the table. And write down sum. Well, let's see. Minus 2 can only be written as a minus 2 and a 1, or 2 and minus 1, right? And the sum here is going to be minus 1, and the sum here is going to be 1. And this sum should be minus 3. Okay, so in this case, we're done. There's actually nothing else we can do here. We can't factor this trinomial. All right. So our final result is just 14n squared times n squared minus 3n minus 2. Okay? Alright. Now, if you end up with a problem, let's say it's x squared plus 4x plus 5, let's say, and you want to factor this. Okay? Well, you'd start out the same way you've always done. Here's our 5, then the sum. So this can only be 1 and 5, right? So this is going to be 6. There's no other options. Okay? And this says, right here, 4. So this can't be factored. Therefore, we say this trinomial is prime. So whenever you can't factor something, you'd say it's prime. So for example, if we just looked at the value, a prime number, right? That's where this name prime comes in. 7's a prime number, but if I said, well, factor this, well, you can't, because I mean, really, the only factors are 7 and 1, right? So you would say, well, this is just a prime number. Now, 6, well, the factor is 3 and 2, right? So the bottom line is when you have a polynomial that can't be factored, whether it's a binomial, a trinomial, or any type of general polynomial, and it can't be factored, you would say that it's prime. So in other words, if we go back to the last section, and I said, we'll factor this, 5x plus 4. So this is just a binomial, or I can even put 5x squared plus 4. I mean, there's actually nothing we can do here. There's no common factor between 5 and 4. There's no common variable, so this is actually prime. Okay? Can't factor, or can't be factored. All right? So just remember that. Every once in a while you'll run into a problem that you can't factor it, so it's prime. All right, so make sure you learn this technique. This technique's actually very simple. You just got to make sure you understand of how to get the right middle term sign. It's easy to get the right number, but you want to make sure you get the right sign, and that's pretty straightforward. So if you follow the notes here, it should be easy for you to do. So make sure you understand this technique, because the next section in 5.3 is going to be factoring same thing, ax squared plus bx plus c, except now a is not going to be equal to 1. So that throws a little bit of a monkey wrench into how we go about solving it. It's definitely different than what we've been doing. Okay, but can't do this, the a not equal to 1, until you understand how to factor when a is equal to 1. All right? Oh, one thing let me just mention here too. I've had a few students, 2 or 3 actually, I think 3, write me some emails about, I input the answer and it's marking it wrong and stuff like that. And I've gone over those, and it's actually not marking things wrong. So when you really have to read the directions, for one. Okay, so one of the problems I think I remembered that if you had 5x cubed to the second power, and you want to write this in exponential notation, okay, it'll say there. write your answer in exponential notation. And some of you put 25x to the 6th. Well, this answer is right if it just said to, simplify. So if this just said simplify, this would be the correct answer. But if it says to write it in exponential notation for the same problem, okay, remember exponential notation, you write exponents on it. So this is actually 5 squared times x to the 6th, right? Because exponential notation is going to be x to some power, okay? So this would be the correct answer, where some of you actually put in this result, all right? So be careful, number one, input what they ask for. The other thing is, let's just say someone had put this answer down, 5 squared, you put the little dot for multiplication and x to the 6th. I mean, is it wrong? No. Did it mark you wrong, for one? If it marked you wrong, I would go back and give you full credit on it. But now you should know that it's not necessary to put the dot there for multiplication. Okay? So every once in a while the computer is pretty good. They give you variations of how you can input it, but if it's just blatantly wrong, then they're going to mark it wrong. For example, someone was wondering about, let's say, this right here, and they put a negative 16, x squared, and they said, well, I think I should get it right. I mean, this is correct, and is this correct? No, because a negative squared is always a positive, so this should be a positive 16x squared. Okay, so when you're getting something wrong, go back and look at what the correct answer is, okay, and really say to yourself, did I do this right and it's marking me wrong or not? Okay, most of the time you're not inputting it correctly or what they're being asked for. Now again, like I said, every once in a while, there may be a situation where, and I'll do this, let's say it says to factor x squared, or not that, let's say it's b squared plus b, we want to factor it, okay, and someone puts x times x plus 1. So they somehow transform their variable b to the x. And of course, the computer is going to mark this wrong, but you can just write me and say, hey, I accidentally put the wrong variable in, and sure, I'll give you, full credit for it. I mean, that was just a silly mistake. We all do that. So definitely pay attention, really, to what's being asked, and go over your results. So when you finish either the quiz or the exam, you can check your answer, what the correct answer is, and then you can also see what you inputted. All right, and I have no problem looking things over, which I have done, but I found most of the time that you're just not inputting either the correct answer at all, or you're not writing it in the form that they asked you to. Okay. Anyways, that's just my little comment there.